Private endpoints allow Azure resources, such as storage accounts or SQL databases, to be accessed securely through an IP address within your virtual network. This approach ensures that traffic remains on the Microsoft Azure backbone, reducing exposure to public internet-based threats. By converging platform as a service, PaaS, resources into your virtual network, you gain greater control over data flow and tighter segmentation of services. Private endpoints fit seamlessly into virtual network architectures, aligning with best practices around limiting public endpoints. As organizations transition from service endpoints to more advanced solutions, private endpoints provide a refined level of security isolation. Configuring private endpoints involves assigning a dedicated network interface to a supported Azure service. This interface, hosted within a subnet, leverages Azure's private link platform to provide private connectivity from your virtual network. One benefit lies in mitigating data leakage risks by preventing public exposure of service endpoints. Additionally, private endpoints promote compliance with internal and regulatory standards, such as PCI DSS or HIPAA, by restricting connectivity to private channels. Organizations can customize security layers around private endpoints using network security groups, ensuring that only authorized subnets or virtual networks can communicate with the Azure service over a private link. Private endpoints integrate seamlessly with existing virtual networks. Before deploying them, administrators typically create or utilize a dedicated subnet, ensuring no overlapping address spaces or conflicting policies. Network security groups, NSGs, can be applied to this subnet, although inbound rules are implicitly handled by Azure's private link service, resulting in administrative overhead. DNS name resolution must be directed to the private endpoint's IP, either through Azure-provided DNS or custom solutions like Azure DNS Private Zones. By unifying these elements, organizations can incorporate private endpoints within their broader network architecture and maintain traffic flows across subnets, peered networks, and on-premises resources. Before creating private endpoints, it is essential to confirm several prerequisites. First, ensure that the targeted Azure PaaS resource supports private link. Common services include Azure Storage, Azure SQL Database, and more. Next, allocate a dedicated subnet in your virtual network with sufficient address capacity to host the endpoint. Also, verify that there is no service endpoint overlap for the same resource, as this can cause conflicts. For name resolution, organizations should prepare a DNS configuration strategy, such as using Azure DNS Private Zones or custom DNS servers, to direct lookups to the private IP address of the service. To provision a private endpoint, navigate to the Azure portal and select the desired PaaS resource. Within the networking blade, choose the private endpoint option and define the target subresource, such as blob, file, or database. Specify the virtual network and subnet where the endpoint will reside. Once created, Azure automatically assigns a private IP and links it to the resource. Administrators may reconfigure DNS settings or create name records to ensure that domain queries reference the newly assigned private IP. The result is a seamless, private connection that secures data transfer and eliminates exposure through public-facing endpoints. In many deployments, Azure automatically updates the platform DNS records to map service names to private IP addresses. However, some scenarios require manual DNS configuration, especially when using custom DNS servers or hybrid environments. One approach is to create an Azure DNS private zone, link it to the virtual network, and add records that point the service's fully qualified domain name, FQDN, to the private IP. Alternatively, on-premises DNS servers can forward queries to an Azure DNS forwarder in the virtual network. Proper DNS design ensures that internal clients seamlessly resolve service names without relying on internet-based lookups. Securing private endpoints involves a combination of Azure-level controls and traditional network measures. Access to the endpoint subnet can be restricted using NSGs that permit traffic only from designated IP ranges or subnets. Additionally, Azure Firewall or third-party virtual appliances can inspect traffic passing through your virtual network. Role-based access control, RBAC, can further safeguard the target PaaS resource, ensuring that only authorized users can manage or access the service. Encryption in transit is managed at the service level, providing end-to-end data protection without additional configurations. By combining these layers, organizations create a robust defense for their private connections. Once privately connected, data packets flow through the virtual network and remain on the Microsoft backbone, eliminating the need for public routing. The resource is accessible using its private IP, and inbound or outbound requests do not traverse the internet. If a multi-tier application requires communication with multiple PaaS services, each resource may have its own private endpoint, isolating traffic flows for auditing and compliance. Peer virtual networks also gain access without additional overhead, provided that proper DNS resolution is in place. This approach reduces latency, improves reliability, and ensures a consistent security posture across distributed workloads. Azure offers several tools for monitoring your private endpoints. Within the Azure portal, you can review connection status and IP allocations in the Private Link Center. Network Watcher enables packet capture and flow analysis, helping to diagnose connectivity problems or confirm traffic patterns. Azure Monitor metrics, such as connection success rates or data transfer volumes, provide insights into resource performance and usage. Log Analytics workspaces gather diagnostic data, enabling correlation with other network events or security logs. By leveraging these services, administrators can quickly detect anomalies, understand traffic flows, and maintain a stable, secure environment for their private endpoints. Organizations often use private endpoints to protect sensitive data within Azure storage accounts or to secure transactional interactions with Azure SQL database. Multi-tier web applications can maintain all components in a private network, reducing the attack surface. Hybrid scenarios benefit from private connectivity, where on-premises resources connect through a VPN or ExpressRoute circuit to access PaaS services over private IPs. Additionally, compliance-driven industries can leverage private endpoints to ensure data never leaves corporate-controlled address spaces, aligning with strict regulations. By carefully designing subnets, DNS, and NSGs, administrators can maximize the effectiveness of private endpoints across diverse workload requirements.